Okay, so I just ended up opening all of the remaining sections for 244. I just went ahead and opened it up all the way to the end. I did a couple posts in week 12, and now we're just kind of wrapping up week 11. I think there might be one or two more. I'd love to hear from a couple other students. Well, and kind of the big picture here is that the fossil fuels are just heavily cooked plant matter that used to be on the surface of the earth. So I think what we're seeing now is these agricultural companies are really just tweaking nature in such a way that they're adding more value to the hydrocarbon products from plants than you're going to get from blasting tops off the mountains or digging up ancient shale beds and all that. So no, it's definitely interesting times. Interesting times. Okay, let me get. Oh, and one more thing while we're on the top, or two more things while we're on the topic of bioenergy. I gotta tweet this or something, but I think my talk is going to be on MCAT tonight. Let me look at that. Missoula TV. Let's see if it's here. I thought summer programs, local live, channel, schedule.
Is there any way to do this online?
I don't know. I think. Let's see the entire. I thought it was going to be on tonight. Zombies of the Living Dead. Thanks. April 14th. Well, let me see. Let me. No, I don't know. Maybe I'll email him really quick. There's that. What else? There was one other thing I wanted to talk about. So maybe they'll come to me. But let's go and look at the papers. Have you submitted your paper yet? Do you have a draft going? Okay. Well, let's just look at term paper guidelines. Again, here are the guidelines. Field trip. Okay. 9. Submit term paper. Okay. So I've got 2 in, and I've got 5 more to go. So I'll shoot an email out, but a couple guys wanted me to take a look, and I'm just going to assume that neither one of these are finished, but I think Nick wanted me to take a look. So I'm not, well, Nick, I am going to pick on you, but I know you've got pretty thick skin, and I was thinking about this on the way over. I mean, we really live in a environment now where, most of what we do is online anyway, and here in academia, the point is to get some positive, constructive feedback before, you know, you share the thing with a full-on peer review. But let me just show you how I typically go through one of these things. I'm right in the middle of reviewing papers, just so you guys know a little bit of other stuff I do. There's IEMBC. I'm a editing member of the IEEE. I think I'm going to hit this conference in August. But what these guys do, so this is the Institute for Electrical and Electronic Engineering. Steve Shen is a member. I'm trying to get a chapter going here at the University of Montana. But these are the types of electrical engineers that will invent, you know, say your CAT scan machine, your MRI, do the Doppler, you know, anything where you're sort of pumping electricity through a circuit and getting some kind of signal back. So that's really what the EMBS is. And so I do a lot of editing for those guys. Okay, so Nick has a good little table of contents going. That's good, nothing wrong with that. Introduction, let me see. Yeah, and so he's also using the headings. That's great. Nice job on that, Nick. Thanks. So when I'm going through here, I'm going to go ahead and just file. Oops. Hello. Did not mean to click on that. No thanks. Don't need help. Not yet. Save as. Courses. 244. Bioenergy. 2016, new folder, paper draft, open, save. Yeah, and then I'll save it in its native form, and then I'll save as. I like to label things at the end with the year, and then the date. Or sorry, the year, month, and the date, and that way when I have subsequent edits, they're always in numerical as well as chronological order. So what I would do, I would take this right here and oh, it looks like I'm missing my macro. No. The macro gets hidden. Why is the macro hidden? Why is the macro in view? Anyway, there it is. Record macro, and I'm going to record this to the keyboard, and my shortcut that I'm going to use is Control-8. I'm going to assign that, close it, and now you can see that funny little cassette recorder, which most people born in this millennium wouldn't even know what it was, but I'm going to turn that font highlight red. And now I'm going to go back to view, click on macro, and stop recording. Now I'm going to put a comma in here and do Control-6, which is my green macro. So the red means get rid of it, the green means put it in. I think convention is to have the comma in front of the quotes. Okay. Is going to treat and return to the environment. I like that. For some people can be sustainable. Get back to the environment. Missoula, Montana. Cool. This is a big deal right now with water, public water. You know, the city owning the water. I guess they're two separate things. You know, Mountain Water does the supply. I think the city owns the wastewater treatment plant. Is that right?
As far as
I think they do, yeah. So 9 million gallons, I want to do some math on that really quick. So 9 million gallons, dink, dink, dink. Those are good numbers. And you know what? I love seeing these numbers in there. You got to have them. So 9 million divided by, Missoula's probably 70,000 by now. I don't know. 70, dink, 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 equals 128 gallons a day, so that's times 8 equals. So we each use a half ton of water a day. So we're processing, or wasting, if you will, 5 to 10 times our body weight in water. It's obviously not all passing through our bodies. That would be a lot of water. It's passing through our, sinks, toilets, what have you. But that's a pretty beefy demand. To have that, 5 to 10 times your body weight, moving through your technology. And this is showering, this is dishwashing, power washing, car washing. There's a lot of industry that has a pretty high water demand. But anyway, good numbers to keep in mind. And every one of these gallons is also tied to some kind of energy consumption, because most of it is going to be pumped uphill before it comes down through the tech. So just that number there in pounds, 1,000 pounds also has some kind of energy footprint. Wastewater. Now, I don't really know how much anaerobic digestion is happening here. I think a lot of it just ends up being sent to eco-compost, the biosolids.
So,
Yeah, so I think there's some human manure going on in Missoula. I don't know if it's separate from the other stuff they've got going, but I've not heard of anybody, getting E. coli poisoning as a result or some other kind of disease. I think it's hot enough that most of that stuff gets cooked away.
Yeah, ECO probably runs them through a process that should kill off most of that stuff.
Yeah, I have not been over there, but that'd be a fun little field trip for me to take. Maybe we'll do that with Mike Holochek before the term's over. Sent to many stages, finally discharged in the river. And I've heard that we do a pretty good job getting most of the nitrogen out of the discharge. Fatty acids, neat, cool. Mostly methane. I had another entrepreneur here in town see if he couldn't commercialize the methane production. I think he needs to say digester here. Mixing process. Biosolids, sort of eco-compost, sewage, hybrid poplar. 70,000 trees, not too bad. 1 tree per citizen. Nice. These are just a few things. You got a couple typos here. Biosolids, so much more gravel. Works. Building screw pump. I don't know, Nick, if you went there or not, but I'd say, consider adding figures, photos. And the way I like to do that is to go up here to insert, it's under references, insert caption, figure comes up, there you go. And again, this is just a suggestion, Nick. You don't necessarily have to put this particular one in, but it'd be great to have a few screw pump. Home. Do this. I like to come up and actually define a new style. Okay, so here's caption. Okay, caption is already a style. And for whatever reason, it's small and blue and some weird font. So change that. Take that to Times New Roman. Make it black. Maybe even take this up to 12-point font or whatever you like. Make that black. And now I'm going to go to caption and right-click and say update caption. Turn that to bold, save, cool. cool. And now you can come in here and say, insert, cross-reference, click on figure, label and number, insert, boom. There we go. And when you put your figure in, insert pictures, I'm just going to put some dummy photo in. I don't know what really looks like a screw pump here. Some old stuff. Fun old pictures. Oh my gosh, yeah. Oh, here's one. Totally irrelevant, but fun anyway. Carbon subsidies. Put that in as the. I would, if you do Control E. So with my left finger I'm doing Control. My right when I'm doing an E. Control E will center that. You can center the figures if you want to. The figure captions. Make that a larger size. Right click on that. Wrap text. And just keep it in line with text. It's just easier. And you can even go up here and create a style. I would just call it figure. Okay, and then under paragraph, line and page breaks, keep with next. And that way the figure style will stay with the figure caption. And let's just go down here and say update figure to match selection. Perfect. Okay, so I'll put all that in green. Control 6. Cool. All right. More treatments, fatty acids. Okay, so there's some pretty big metabolism going on here. Fatty acids feed the other bacteria. Good detail. Same thing up here. Sewage treatment plant. Oh, I should put that nice little. Well, this is also good. All I am good integration. One thing that I've been thinking about and obsessing a lot over is just like the mass flow, and we did a lot of that early on in the book here. You know, conservation of mass. Like, where do all of these molecules and atoms end up flowing? So, in this case, I love the fact that he's talking about, you know, where the matter goes after it leaves the plant. 'Cause it's going to keep moving. That's been the key to my own zero waste thing. Is you just got to keep that stuff moving. What did I see? 9 million. 95 degrees, 90. Oh, good equations, man. Oh, that's great. Okay. Here we go. All I am, good detail. Or I should say good quantitative detail. 9 million gallons. Perfect. All right, let's do a little math here before we... Fahrenheit. This is just a spelling issue. No problem. Fix that. But again, though, all I am good quant. Getting lazy. Heat digestion. Talk about.
Do you rather see it spelled out or symbol?
Well, there is a way. Actually, I kind of like in here if you use the backslash DEG, it'll give you that. You know, and I think you can assume in this for this course that your audience is technically savvy enough to know what the circle. If for some reason you were writing to a non-technical audience, you might write out degrees Fahrenheit, but for here, 90 symbol degree F is probably more appropriate. Yeah. I think he wants to say digester, not disaster. It's pretty funny. The disaster. Acidosis. or no, acidogenesis, methanogenesis, nice. Centrifuge, biosolids, eco-compost. 30 acres. Yeah, here's something, biomass could have the, maybe the equivalent of 9.5 terajoules of potential energy. That sounds fine. I'm not sure I would use the word potential energy there. Add to dictionary, terajoules of yeah, maybe available, yeah. And I think in this case, you really don't need equation 1 here. It looks to me like maybe, here's what I would do instead. I would put a paren there, I would put another paren here. I'm going to go up here, I'm going to do Control-Shift-8. So Control-Shift-8 shows me all of the white spaces in the document. And since you've got all 3 equations as one, that's fine. I'm going to come to the center line and come up and throw in a center tab. I'm also going to put in a right tab and take these 3 characters. I'm going to do Control-X. I'm going to pop up 2 lines. I'm going to hit the end key, and I'm going to go ahead and hit Tab, and I'm going to hit Control-V. And I just took the 1 and stuck it at the end of the line. Now it's kind of screwed up, so I'm going to hit the Home key, and then I'm going to put a tab in there. So you can see that the equation itself is now on that center tab, and the equation number is on the right tab. And you really don't need this. You can put a colon there, and then you can put a comma here. Oops. Maybe not. Sometimes it's more. Yeah, I just put a comma in there because you want to treat the equations as part of the sentence. You want to read it as 5,000 tons times 2,000 pounds per ton equals 11.2 million pounds. Put a space in there. Always have a space between your numbers and your units. You could even say something like this. Well, you might want to put some language in there. Not that big a deal. Another thing, though, is you do want to make sure that the units themselves are not italicized. That's kind of a bigger deal for scientific literature. So no italics, no italics, no italics. There we go. And now now he takes it down to 19 megajoules per kilogram. Let's just double check on that. That sounds about right. Energy density of wood. Oh, I do know what I was going to talk about. I knew it would come back around. Yeah. Remind me, we need to talk about the Kardashev limit here. Fat, diesel oil, dimethyl. Let's do scoop Control F for wood. 18. Okay, so he's in the ballpark. 19 megajoules. Again, put your spaces in here. No italics. Spaces. No italics. Yeah, Nick, this is actually some really good engineering language that you're using here to put in both units. You say, okay, I've got 9 million megajoules or 9.5 terajoules. That's exactly how one does engineering. That's perfect. Very clear and concise. Yeah, and this is, I'm just going to kind of get rid of that. I don't know if it's going to screw up the table of contents or not. Let's just update it and see what happens. You don't necessarily have to put in your equations. There might be a way to come up here in the table of contents and reference this guy. Let me just see if I can find him again. Edit field. Okay, sequence equation. Yeah, so you've done this exactly right, Nick. Nice work. There might be a way in the table of contents to add those sequences. You figured it out once. I'm sure you can figure it out again. And so, anyway. Now, but here's what I want to show, though. My son was just taking me through this thing known as the Kardashev limit, or the Kardashev scale, and I keep stating that humanity is in a okay. Kardashev was mainly concerned about uranium consumption or nuclear consumption, but the way it is defined, a type 1 civilization is one that consumes all of the incident sunlight on planet Earth. And if you look, this is totally appropriate for bioenergy. So if you look, Kardashev, type 1 is so here's Earth, here's the sun. And right now we're running at 16 terawatts. And if I'm not mistaken, the sun is hitting us with something like 160 terawatts. I believe that tera, which would be 160 petawatts. Let's see if that's correct. Petajoules of energy. 180 petajoules. Yeah, so if you're using 180 petajoules per second, you're basically running at 180 petawatts, which is pretty close to the 160 petawatts that I just mentioned. So I think that's why this is his petajoules. 2 orders of magnitude producing antimatter. But so if you look at this, these two ratios, 16 terawatts to 160,000 terawatts, we're at a 0.0001 Kardashev type 1. I'll just write it like that. But I'll be danged if my son did not find some other website out there that said, well, it was actually a pretty talented, it was sort of like a Khan Academy kind of deal, where the author said that our civilization is running at a 0.75 type 1, which is almost almost four orders of magnitude greater than what I've been looking at. And the issue is, well, there's a couple issues. One is that you're making a lot of heat. And if you're using, fossil fuel-based energy, you're making a lot of greenhouse gases. I think that's why these guys are talking about antimatter and nuclear fusion and all that. So, you can still have a lot of energy per capita without the greenhouse gas effect. The issue I'm coming back to, and this is just coming back to Nick's paper here, is these, 96.5 terajoules. Let me just write that out here too. So this is back to Nick's paper. So I'm trying to tie in, our little, micro carbon economy, stuff flowing down to the sewer system, making trees, then that becomes energy. What would we say, 96.5 terajoules? So 96.5 terajoules, and this is basically sitting in that 140 acre 73,000 tree plot. That's where that energy is. But my challenge to that statement is, isn't that energy also sitting in the atmosphere in the form of all the oxygen bonds, right? Because the only way to, release the energy from the trees is to burn them, I think. Because basically what happened, in the so-called, natural manufacturing of the tree, well, let's start this way. The trees start out small, little tiny stubs. So the plot, the poplar plot, becomes an oxygen source, right? Because the photosynthesis is making oxygen as a waste product. So, but if you're going to get that energy back, you're going to have to bring that oxygen back in to then, do combustion. I think that's kind of the big trick here. Is like, isn't part of this 96.5 terajoules sitting out there in the atmosphere? Where did that come from? Well, it came from some other tree or some other plant somewhere. Where did that come from? Well, it came from your photosynthesis. And so I guess, there's your carbon cycle, if you will. And the point of being carbon neutral is that this arrow somehow becomes bigger than this one. The oxygen sources become greater than the oxygen sinks. So that's something, Nick, you might want to just touch on in your paper. There you go. Well, I like the way you end this up. I think Missoula's wastewater treatment plant can become a model. I don't think we're unique in that. I don't know whether countries are doing something similar, but and again, one thing, guys, I'm going to have a talk with Reeve Tennell this afternoon. He was one of our grads a couple of years ago who's looking for some new technology to get into, and right now I think we're poised in a pretty good place to share some of the carbon sequestration technologies that local entrepreneurs have come up with, and maybe really make Missoula a hub for some of this innovation. So hopefully and I've got a couple guys coming in, some financial folks coming in tomorrow, and some other ones we're going to talk to on Monday to see if they can't get the economic ball rolling behind it. So get some Google money. All right. Well, that was a lot of fun. Let me see if there's anything else we're kind of missing back in the in the website. Oh, so Nick, I'm going to save this. I'm going to go back in. I'm not, yeah, I'm just going to, Nick, I'm just going to give you a grade of 50 for now. Doesn't mean is it just because you're kind of halfway there? I just want to see the things fixed that I did. You know, Nick, please watch today's video. Make suggested edits. Nice work overall. And then I'll just put this paper back in there, recent places, date modified, paper draft, Kruger BEL, upload. Away we go. This is the most annoying part of grading for me, is just waiting for the upload, download thing, because I know I can save and show next. So yeah, so I've got 2 out of 5 papers in. So what you'll see here is just something. Yeah, well, knock something out. I'll just say, Jason, please submit draft. Your assignment is to get Brian Davis back in the program.
I haven't heard anything.
I haven't either, man. I feel really bad. I just feel terrible that he left. I also feel bad that Tanner Truant hasn't been seen or heard of. I have had some other pretty cool students coming through, but anyway, I'm still optimistic. I think we'll get her done. A couple of 37-minute videos.